You're recording? Is that okay?
Yeah, sure. Okay. Oh, okay. I'm sorry. I forgot to record actually. So yeah. Thank you. Thanks for the notification. So, all right. So, okay, so here it is. So here when we are translating a program to machine understandable format, that is zeros and ones or something like that, then there are two different ways a program can be translated. Number one, it can be an interpretation type translation, means each line will be interpreted to machine understandable language once and then execute and then go to the next line. So it is just like, let's say you have got a English paragraph and you want to translate it to Spanish. So you are just reading it to reading one line, translate to Spanish, go to next line, translate to Spanish, go to next line, translate to Spanish, something like that. The other way is compilation type of translation, where basically you read the entire English paragraph and then just do a overall translation. So this Python is actually interpreted type language, what we are going to learn, whereas Java, C++, and some other languages are basically taking the compilation type of strategy to convert to machine language. So like that. So that's about preamble of programming. So at this point, I would like to stop for once because we are switching to Python, and I'm open for questions, if there is anything.
You should just be able to unmute.
Yeah, I think so.
Or I can watch the chat.
All right. So yeah, sure. I mean, if you have any question, as Dr. Lawler said, you can write in the chat window anytime, or you can unmute yourself and then you can start talking. Thank you. So anyway, we are moving to our Python part. Hope you have understood the basics of programming, what it is and why programming is required, what it can do for you and all those things. And now let's say, let's learn about Python, which is the major part of this workshop. So here is a brief history of Python. Python was actually invented by Guido van Rossum, a Dutch scientist, and Python actually maintains its two different versions. It used to maintain nowadays. So it has a Python 2.0 and Python 3.0 version. And well, Python 2.7 actually was supposed to discontinue around 2015, but at that time the data science took its peak in the market, and that's why Python suddenly started getting popularity, and that is the reason they could not obsolete the 2.7 version, because there were lots of people, lots of industry, lots of clients were using that version. So they just, it was actually decided that, well, after 2020, they will only maintain Python 3.0 just to give the clients enough time to convert their legacy code base from Python 2 to Python 3. So it gained that much popularity. So now you can understand how popular Python is. So they just delayed the discontinuation by 5 years for Python 2.0. Anyway, we will learn Python 3.0 in this course, but why Python? Python actually, at its core philosophy, Python actually says like the readability counts. And the major thing about Python is this core philosophy, which tells simple is better than complex. So by using Python, you can write a program significantly simpler way compared to C++ or Java or any other programming language. That's why Python is so popular among everyone. You can learn Python very easily, and you can be productive with Python very, very, very easily. So as you can see, since because of those core philosophies, because of its ease of use, and it is becoming like very popular, and according to this ZDNet or many other website, Python is possibly the most popular language nowadays. And what happens actually, since it is easy to use, everyone from the domain scientists or domain engineers or domain experts basically started writing different types of libraries, like data analytics libraries or like scientific analysis libraries, many different types of libraries. Now, and once they started writing the libraries, your programming started becoming again more easy for you. I mean, easier for you. So that's where the virtuous cycle started, and Python is gaining the popularity. More library means easier programming, and easier programming means more library support. And of course, there are lots of job openings, especially with the introduction of data science. It became the top choice for machine learning projects, AI projects, or big data analytics project, and all these things. And that is why you should learn Python everywhere. In most of the industry today, they need some kind of Python experts for their job. So now let us start our first Python program, and from here we will start our some hands-on exercises. So all you need is a Google account and Google or Gmail account, and you have to, we will do everything in Google Colab environment. So by the way, before going there, let me, so can you please raise your hand if you already know what is a Google Colab? If you know, please raise your hand. Otherwise, it's okay.
I see 0 raised hands.
0 raised hand. All right, perfect. So, well, first of all, this Google Colab is a great tool to write your prototype. You really do not need to worry about any type of installation or anything like that. And well, so let's start without wasting time. Let's start with Google Colab. So as you can see, the Python first program is so easy. It's just one line of code you can write. And so let's see how to run it. So here is a slide. Sorry, it's a little bit messed up. I don't know how did that happen. Anyway, so let me switch to my all right. Okay, so something happened. So can you all see my website? I mean, website, the Google Chrome browser?
Yes.
All right, perfect. So here, all you need to do, if you already have the alaska.edu account or anything, whatever, just open a normal Google Chrome window and just type Google Colab. All right, you can just search it. So the actual website is just like colab.research.google.com. That also you can type. Sure. Thanks, Dr. Lawler, for sharing. So the chat window, you can get the link actually. So anyway, here, if you just click on this Colab notebooks and like that, it will take you to this type of a dashboard kind of a window where, I'm sorry. So it is. Oops. So file here, actually, you can get a new notebook. If you click the link on the chat window, it will take you to this website. And here you can click on this new notebook. And once you will click this new notebook, it will ask you that you have to sign in, where you can sign in just by using your Alaska account. So let me just sign in just to show you. So here, just next. So, oh, okay. So I just missed the A. So like this. So, and it will open an Alaska, open a Google Colab for you. Now here, basically, you can start writing your code. So now let me just show you how easy it is to write your first program. And then I'm going deeper into Python. So Cody asked, is the Google Colab the same as using text editor app? Yes, it is. You can use any type of app that you want. It's all about Python code. It may run in Google Colab, it may run in any other text editor, it may run your other online editor, online compiler, your local machine installation, but it's Python. It's all same. Okay, we use Colab because it gives us a little bit facilities regarding presentation and running the code, modularizing and all these things. That's all. So anyway, so here in the code lab, so let us write our first program. We can just do like, let's say if I want to print a hello world in Python, all I need to do, there is a function called print here. And then after print, there is an opening and closing parenthesis. And then you can write just hello Python or hello world. And then there is a small, this triangle type of button over here in the Google Colab, and you can just click on it and this code will execute. So here you can see the output of your first Python program. All right. And after that, if you want to add some more code, what you can do, you can just click on this plus code button, and here you can keep on typing whatever you want to do. Now in Python, it's easy. So if you, let's say, want to do some kind of arithmetic operation, let's say 3 plus 4, what you can do, just write 3 plus 4. And if you just click on it, then you can get 7, the answer. Makes sense? So are you all comfortable? Are you all in Google Colab? And can you follow all these things? Can you run your first program? Any question or confusion? All right. So here it is. So anyway, so if you are okay in Google Colab, so is there a keyboard shortcut for run in Colab? Well, that I'm not really sure. I did not use it. Possibly there should be something, of course. Here it is, Control Enter, as you can see here. So you should enter Control and then Enter. It will run this for you. Okay, so that's it. So, all right, let's move to the next piece of code where we are going to learn about more Python. So I already have created a Google Colab that I'm going to share with you. So all you can do is you can just copy paste this code. I will modify this code and you can start typing with me and like that. All right. So here is a small instruction for how to use Colab Notebook. You can use this plus code above to run the Python code block, and you can add a plus text over here to add the text just like this. So you can take like, let's say 1 minute to familiarize yourself with Google Colab, and you can write these first 2 blocks of code just to get yourself comfortable in this new environment. And if you get any type of trouble, please feel free to write in the chat window, or feel free to unmute yourself and you can start talking. All right, I hope all of you got a little bit, chance to familiarize yourself in Google Colab. And so now let's go to the next part of our program. Now, one more thing that I would like to say in Google Colab, one way to add some comment or the text description is to add a text box just like this. Or if you want to add some comment in the code window, you can always use it using this hash. All right. So this, let's say hash print a text. It will automatically, the Python interpreter automatically remove this when it will execute the program. This is called comment. These can improve the readability of the program. You can add some explanation, text description for your code like this way. So like this. And also in a Google Colab, it's not like you have to write only one line of code in one block. You can write as many line of code in one block as you want. You can write the entire program in one code block, no problem, but we normally don't do that. We always want to modularize it, and we want to present it in a pretty nice way. All right, so that's about Google Colab. And now let's go to the next piece. So now let us start learning about the Python basics. So any type of programming language, whatever you will encounter, there are some basic building blocks, which are basically data types, identifier, operators, and keywords. In Python also, those concepts are there. So let's learn a little bit about all those concepts first. So I will just go over the PowerPoint to explain the concept, and then I will switch back to Google Colab so that you can get yourself, so that you can type some code. We will do some hands-on. So first concept, so the point of learning all these concepts, once you will get yourself familiarized with these data types or operators or this looping or all these type of concepts in one programming language such as Python, you will not have much problem in switching to any other language. So that's how this workshop is formed. We will just go over all the concepts that are common in all the programming language, and then we are going to learn the Python syntax to make it more lucrative. So all right, so data type is basically a particular type of data item as defined by the values it can take. Now, if we analyze the digital domain, and if we go to the fundamental data type, fundamental types of data, we will see that they can be mostly divided into 2 or 3 different categories. The first one is a numeric value, where the numeric value can have a decimal point and may not have a decimal point. And when it has a decimal point, it is an integer, otherwise it is a floating point number. Then there is a full, it can be a full text or a single character, which we call it a text. Now in Python, basically single character and text are all same, but there is a little bit difference in with some other language, but we are not going into the detail of that. So just remember, in Python, there are like 3 different things. One is numeric value, the other is full text or single character, and then the third type is this just true or false, yes or no, or just like 0 or 1, which are basically called Boolean data types. All right, so Python supports these fundamental data types. And now let us have some experience with hands-on experience. Now, so let me switch back to Google Chrome. So so in Python, and well, so before going to this hands-on, let me just clarify another concept. The other concept that you need to know, the very basic concept, is identifier. You can call it just a variable. All right, you all have used variable in your mathematics or any type of problem solving, right? Now it's just like variable. It's just like writing x equals 20, or age of a student is 30, or something like that. So here, identifier in programming is basically a memory location inside the computer, which is given a name for its identification. That memory location can store any single data item. Now, in Python, we call it a variable, or in any programming language, we call them a variable. It's a named memory location, and it can take any type of name like I, C, all these different types of things. It can be B, it can hold Boolean data type, it can hold floating point data type, and everything.
The Boolean is case sensitive, like capital T true.
Oh, yes.
It just
So
screwed me up.
here, exactly. So here there is a small problem in my PowerPoint.
But the classic case of how programming languages are like capitalization matters. It'll flip out if it's a word it
Yes.
recognizes, but it's not the right case.
Exactly. So yeah, I mean, Python is a case sensitive language. So let me switch back here and just let me show you what happens. So here are some of these identifiers and data types example. Now it can be like, let's say age equals 35 and then name equals Alice. So age is a variable identifier, name is a variable identifier, and age of Alice is 35. That's an identifier, something like that. Now, if you want to store a Boolean number, let's say is valid or something, is valid, or now if you do like true, something like this without with all small, and you will see that it is giving you an error because true is not defined, because Python is case sensitive. So if you want to store a Boolean true, then you have to write in capital letter. All right. So now if you just write it, everything is working fine. And this age is storing 35, name is storing Alice, and like that. And here are some naming rules you have to follow when you will give a variable a name. A variable name cannot start with a number. For example, if you just add a number in the beginning of this age, as you can see, it got a red underline, means it is error. So like so, and that's one thing. And also, any of these variables cannot have any other special character other than underscore. For example, let's say if I give a star or something like that, and it will not work properly because star is not identified, is not a valid character for a variable name. So these are the two different rules that you should always remember when you are naming the variable. And now, in order to be a good programmer, you should give some meaningful name to the variable, not like the slide like I, J, K, L, but like this code, like age, name, age of Alice is valid, something like that, which makes sense to your concept. So, oh, okay, sure. So can you see it now, Cody? Is it visible? All right, perfect. So, okay. So now, so that's about the identifiers. Now let us learn a little bit of data types in Python. So Python is basically a dynamically typed language, means the interpreter will automatically figure out what type of data it is. For example, let's say I is a variable, although it is not a very good variable name, but okay. I'm just using it for the demo purpose. So let's say I equals, I store like, let's call it like 10.98. All right. So what do you think it should print? Now, if I just print I, it will print the value of I. Now in Python, there is a function just to check whether Python identified the same, the actual data type of it or not. You can always use this type function to check the data type. So type I will give you the type of the data. So what do you think? This I equals 10.98. Of course, it is a floating point number, right? So if you just run this program, you will see that Python identified the data type properly and it is printing float over here. And if you just change the data type to some kind of, let's say some kind of integer, let's say just 10. And if you just run this, you will see that Python identified it as int. All right. And then if you just, let's say some kind of name or something, let's call it Alice, you will see that Python identified it properly as a string. And not only that, everything, if you do like just true with capital T, of course, then it will be identified as Boolean. All right, so that's the most basic concept of programming, or let's say the data science also. What are the basic types of data available in digital domain? And Python identifies all of them automatically. That's why Python is so popular. It does lots of different things for you. Any question? All right, so let's take 1 minute, let's say 1 minute to type down all these things, I and then this type I, so that you can get yourself familiarized with different types of data. So this code block and this code block. All right, I hope you already typed and you are kind of a little bit familiar, make yourself comfortable with this use of variable names, identifier, and different types of like types and all these different things. So if you are okay, I mean, is there any question, by the way? All right, if not, then let's go to learning about operators. All right, so first let us move again to my PowerPoints, and then I will switch back to this Google Colab. And so operators. So operator, you are all familiar with the concept of operators. Basically, if you have gone through a high school mathematics or anything in your childhood mathematics or everything, there are the concept of operators. There are plus, minus, multiplication, division, less than, greater than, lots of different things which are basically serves as operators in there. Now, operator, just to define it formally in programming, it is basically a symbol that tells the compiler or interpreter to perform some specific mathematical, relational, or logical operation to produce the final result. Now, in your mathematics or in most of the problem solving domain, you have probably used only arithmetic operator or some kind of relational or comparison operator like plus, minus, or less than, greater than, something like that. Now, in programming, since it is dedicated to represent your real life in your virtual domain, they needed to support some extra different types of operators. For example, this logical operation and all these things. So now let us learn more about these operators, different types of operators that are supported in Python. And most of these operators are kind of similar in all the programming languages, but we will focus mostly on Python here. So let's switch back to Google Colab again. Now let us start learning about Python operators. So let us start with the easiest one. The first one is arithmetic operator over here. So common arithmetic operators are, of course, plus, minus, multiplication, and division. And their meaning is exactly same in Python also. For example, what I am doing here is, let's say there is an identifier or variable called var1, which is storing 8, then var2, which is storing 5, and then there is a result, which is basically storing the value of var1 plus var2, which means 8 plus 5, which will give you the result of 13. And now not only plus, but as you can imagine, like multiplication will work as the same way, like 8 times 5 is 40. If you do like division, then it will do like 1.6. And then if you do like minus, it will print 3, because 8 minus 5 is 3. Now, other than these common arithmetic operator, Python also support a little bit of some extra operators. For example, these things like, let's learn about that. So here, basically, let's say this var1 and var2 is still 8 and 5. Let me just get rid of these two lines just for the sake of understanding. And now let's do result equals. You can start typing with me also. So result equals, let's say var1, 2 division symbol one after another, then var2. All right. And then if I do print result. All right. So now this 2 division symbol one after another, what it does is it's basically an integer division. It just keep the part before the decimal point and ignore anything after the decimal point. So this is called an integer division. Sorry. So that is called an integer division where the result is 1. 8 divide integer division 5. The part before decimal is 1. The next one is result equals, let's say var1 star 2 star one after another. And this basically stands for the exponential operation, that is 8 raised to the power 5. And this is becoming like 8 raised to the power 5 is 327668. So this is basically raised to the power. All right. And also there is a concept of this percentage symbol, and which is totally different from mathematics. It is not percentage in programming. This symbol is called modular or remainder operator. It basically gives you the remainder part of the division. For example, result equals var1 remainder var2, which means 8 divided by 5. The remainder will be, for after an integer division, the remainder will be like 3, right? 5 ones are 5 and the remainder is 3. So if I just do like this, so here print result, as you can understand, the result will be 3 over here. And because this is the remainder operation. So these are the 3 extra operators that may looks like a different from your mathematics, but of course the concepts are there in mathematics. So take, let's say, 30 seconds to get yourself familiarized with these 3 different operators. All right, so any question on these different operators, different arithmetic operators? If not, then let's go to the second type of operator, which is a relational or comparison type of operator, which is also very common in our real life. We always compare 2 different things, whether it is less than or whether it is greater than or less than or equals or something like that. So here it is. What it does basically, if we try to define it, if we try to look at it more formally, what it does, these relational operator basically compare the left and right values, which we normally call the operands in the program. Just the values that appears in 2 different two sides of the operator. That's just a formal name. And the result is definitely Boolean, that is true or false. There is the returned result is Boolean. Now, when it is true if the left relates to the right with the usual meaning of the operator. All right. So for example, example will clarify the concept. So let's say var1 again 8 and then var2 equals 5. Now what I am doing, result equals var1 greater than var2. So what it will do is this Python code will check whether 8 is greater than 5 or not. And now, as you can understand, 8 is of course greater than 5. So the returned result will be true. So if I just print the result and if I run it, you will see that it is printing true. All right. Now, just as you can understand, if I just do it like less than, then if I run it, it will just return false because 8 is not less than 5. All right. And also there sometimes I have seen there is a little bit confusion about this less than equals and greater than equals symbol. So always remember that greater than equals means so let's say, sorry, this is less than equals means it is either less than or equals. If it is if either of them are true, they will return true basically. But here 8 is neither less than 5 nor equals 5. So what will happen? It will return false. On the other hand, again, the same way, if it is greater than equals var2, it will just check like greater than or equals 5. So here 8 is greater than 5. So it will return true over here. All right. And just to give you the idea, more practice. So like, let's say 8 and 8, I just made it same. So just try to think what will be the output. Should it, if I use this greater than or equals symbol. So here it will check 8 is greater than or equals 8. So which is, just think about for a couple of seconds. Is it true or false? So if you have thought that this is true, then of course you are right. All right. But if I just do something like this, greater than, and then just greater than, 8 is greater than 8, of course it is not true. That's why it will return false. Any question? All right, so that is all about the greater than and less than, greater than equals and less than equals operators, which are pretty common in your real life. And I'm pretty sure you all are aware of this concept. But in order to facilitate programming, the Python needs to support 2 extra operators, which are the equality check and inequality check, which are basically checking whether the values are equal or not. So here, let me just comment out this thing. Now the value of var1 and var2 are now equal. So let's do something like this. Result equals var1, then 2 equals symbol one after another. var2, this 2 equals symbol one after another means it will return true if both the values are equal. And now if I just print the result here, and as you can see, it is printing true because 8 equals 8. So right now it may not make much sense, like why do I need to check the equality? But in a real life situation, you have to check the value of a variable with some predefined value or something to determine the programming sequence, which line of code you will execute. So this is a very important operator. And here, if I just change it to 5 once again, now it will give you false. On the other hand, just the opposite thing is done by this not equal symbol. So not equal symbol, it will basically return just the other way. It will return true if both the values are, if the values are not equal. All right. So here now it is 8 is not equal to 5. So it will return true right now. All right. And if you just make it like 8 and 8 over here, it will return false right now. So these are the 2 different things that is a little different from your mathematics concept. I mean, not the conceptually different, but you may not see these operators in your mathematics, but it is there in program. So let's take like another 30 seconds to write these programs. So get yourself comfortable with this equal operator or this not equals operator. All right, any question? Are you all done with typing the code or any type of confusion or thoughts?
Yeah, I would like to know if this comparison operator works with letters too. If I put var1 a name, var2 another name, with we work or just numbers?
Great question. So let's see. So like this, right?
Yeah.
All right, let's do the same thing and let's check this equality thing or inequality thing anyway. So var1 equals var2. That's what your question was, right? So let's run it. And as you can see, it is giving true because Alice and Alice are same, right? And now let us just change it to small case Alice. Let's see what it does. And as you can see, it is giving you false. So yes, it is working for string or text also. Make sense?
Yes, thank you.
Great. Thanks for asking. Any other question?
If you forget double equal and you put in single equal, does it silently fail or does it error?
Exactly. So that's a very good question. So yes, so var1 equals var2. What will happen here? So we cannot see the difference here, but when I will explain the concept of if and else, I will explain that concept definitely. If you use just an equals instead of two equals symbol one after another. So here, if you want to do that, it is definitely going to give you an error because of some statistical, I mean, some conceptually different things, but I will explain it while explaining if else. All right, so any other question? Okay, if not, let's move to our next operator, which is called logical operator. Now, the easiest way to view a logical operator is just to see it as an extension of the concept, this relational or comparison operator. It basically combines two or more comparison. So two or more comparison can be combined using two different ways. One is and type of comparison and another is or type of comparison. In our real world, this type of situation is very common. Let's say you want to go to a party and you thought that, all right, if my friend Alice comes and if my friend Bob comes, if both of them comes, then only I will go to the party. So if my friend Alice comes and if my friend Bob comes, then I will go to party. That's one way of combining two different conditions. The other way of thinking, if my friend Alice comes or if my friend Bob comes, I will go to the party. If one of the event is true, you will go to the party. You're going to the party event is also true. So those are the two different ways we can combine two different conditions. So now let's see what happens. So and means, just to give you the formal idea, the simple thing that I have explained, it is just the result is true only if all the comparisons are true. Means your friend Bob came and your friend Alice came. Both of them came, both the events are true. So you are going to party, that is true. And or means it is just false only if all the comparisons are false. Means either of them are true, means you are going to the party. Either of your friends are coming, you will go to the party. So let's see these things in action. So let's say there is a comparison equals true. And then let's say I have taken a variable called comparison2, which is false. And then in the result, I am storing it comparison1 and comparison 2. So now this and is basically a keyword in Python, which basically combines two different Boolean expression. So now if you easily understand that comparison 1 is true and comparison 2 is false. So if they are combined using this and operation, it will give you false over here. All right. So that's what it is. Now, instead of just writing true or false over here, what we can do, we have all learned about these relational or comparison operator, right? So let's just give something like this. Let's say it was true. So let's say 8 equals 8. All right. These things also you can, this is a comparison, right? Or, and then let's say this is a false. Instead of doing that, let me just replace it with a real false comparison, which is, let's say 5 greater than 8, something like that. All right. And now if I just run it, you will see that still it is working. And this is how you can basically combine two different comparisons together. Make sense? Any question? Did you understand it, what I just did in the program? So first I have showed you just like how to combine these two, true and false, and then I just replaced it with some kind of real comparison. And that's how you can combine two different comparisons together. Make sense? So this one is basically a true type comparison. It will return true, and this is basically false comparison. All right, and that's why the result is false. So now let us try all these different types of things. So let me just add one extra code block over here, and let me just write it down. Let's say let's see all the different type of combination of true and false. In Boolean algebra or in Boolean logic design, we call them basically a truth table. We basically compare all the different outcomes of two different events maybe, and how they can be related. So let's say there are two different events, either of them can be true, or both of them can be true, or both of them can be false. So for all those different combination of true and false, what will happen? Let's see that. So let's do like this. Instead of using any type of variable, let's do something like this here: true, then and true. All right. And let's say, let's start with false here, and false, and then let's say false over here. And also it can be something like, let's say false and true. All right. Then let's say true and false, and finally true and true. So just assume that there are two different comparison, like comparison 1 and comparison 2. Sometimes both the comparison are giving the result false. Sometimes the first comparison is giving result false and the second one is giving true. Sometimes the first one is true and the second one is false, and finally both of them are true, something like that. So these are all the different combinations of outcomes of a comparison that you can think of, right? So just take like before running the program, just take like, let's say 30 seconds to guess the output, what it should be. Should the output will be false or true? So here it is, the output. So just write down the output by yourself and then run the program. That way you can easily understand what is happening. It will give you some exercise for brain. So if you are done with thinking, then just this line can give you the result. Actually, it is only true if all the comparisons are true, if it is an AND type of operation, right? So the first one, both are false, so it should be false. The next one, one is false, so this is false, and this one is also false, and this one is true. So if you just run it now, okay, so sorry, so I have to use this print over here, and then only you can check the output like this. All right, so now if I just run it, as you can see, everything is false, but the last one, which where both are true, it is true only. Now let us just change everything to or instead of and, like this way. Or, so now of course everything will change. So again, let's take like 10 seconds or so, 10 to 15 seconds to think about the output. What will be the output over here? This line can give you the output basically. So again, as you can understand here, it is false only if all the comparisons are false. So that means the first one will be false. Otherwise, everything is true because either of them are true basically, and the final one, both are true. So true. So let's run it now. And as you can see, the first one is false, but everything else is true. So that's about the comparison operator. I got a question. Is there a way to run a single line of code within? I don't know whether I have understood your question. So it's, are you thinking like this?
Yeah, I was wondering if you have an entire block of code, is there a way to just run a single line so that you can see the output of just that single line before moving on?
Yes, like this. So just run this one and then let's say add another code block.
So they have to be, so they do have to be individual code blocks then?
Yes, they
Okay.
have to be individual code blocks. Yeah.
Okay, thank you.
Yes, yeah. So here, let me just Control Z, and here is the output, everything together for OR. So these things have actually a name in Boolean design. It is called a truth table, which gives you in tabular format, you can note down all these different things basically. So, that way you can get all the combinations and results. So that's about these and or type combination. Any question regarding the operators? I mean, these logical operators. Okay, if not, then let's move to the next type of operator, which is assignment operator. The first one is, of course, the easiest assignment operator is, of course, the equals symbol, which is common in everywhere. It's not only mathematics or program, it's everywhere. It's the universal assignment operator, this equals symbol. So what it does is it basically stores the right-hand side value into a left-hand side variable. Sometimes in some students, I have seen a tendency like, they think that the left-hand side can be also stored in right-hand side, which is not true. Always the right-hand side value will be stored in the left-hand side variable name. Okay, and it does not need to be only a value. You can store another variable into this one also, like this. So let's say this is x equals 10. And then var1 equals x. So what it will do basically, store value of x in var1. And this one is basically store 10 in x. All right, not the other way. Always remember that. So that's
difference from math.
Yes, exactly. So yeah. So that's the easiest way. I mean, that's the easiest assignment operator. But to give some facilities to the developers, Python supports some extra, a little, not complicated, but some compound arithmetic operations, or compound assignment operations also, where basically you can do like an arithmetic symbol followed by an equals symbol. Which means like, well, first it will perform this arithmetic operation with the right hand side value, this left hand value and this right hand side value, and the result will be stored in the variable once again. So just like this, var1, let's say the var1's value is 10 right now, right? And then if we do like var1 plus equals 1, so what it will do, it will first add 10 plus 1, 11, and then again store it in var1. So if I do something like this, you will see the value is 11. And it's not only for plus, you can have any type of arithmetic operation that we have seen, like let's say minus equals 1. So 10 minus 1, it should be 9. And let's say this multiplication, 10 times 1 is of course just 10. So it will be like that. Like so, the division and the other arithmetic operation also. So it is possibly a very good time to do a little brainstorming. Let's say instead of 1, instead of 1, I can use like 2 also. So let's say 10 times 2, it is 20 and something like that. So now let's do a little brainstorming. So just to remember what you have learned, what will be the output of this operation? 2 multiplication symbol, one after another, and then 2. We have just learned about this 2 multiplication operation, right? What is the meaning of it? So if you go to the operator part, if you are typing the code, you will see that this is basically an exponential. So it basically means 10 raised to the power 2, and then the result will again store in var1. So the result will be 100. All right. And not only that, just as a brainstorming exercise, you can do this double divisions. And let's say instead of 2, I am changing it to 3. So what should be the output over here? So let's take like 2 seconds. Just if you have forgot, just go up and then just figure out what is the value over here. So that's all about different types of operators. And as you can understand that this is just giving you the integer part of the division, and that's it. So that's about the different types of assignment operator. Any question regarding operators? All right, if not, now let us move to this input operator, which is basically a function. I should not say operator, but well, sometimes we use it. And Python actually supports a function called input, which using which you can basically read the input from the user. For example, like let's say var1 input, enter a number like this. What it will do is, if I just run this program, you will see that it is asking me for entering a number. And once you will add this number, like write 10 or something like that, then if you hit enter like this, it will print the number is 10 for this line. So as you can see, the 10 is stored inside this var1, the user's value. But there is a problem. What is the problem? Let's say if I do this var1, var2, and like this, what will be the output of this program? So var1 has 10, var2 has 20, and if I do like var1 plus var2, what will happen? How many of you are thinking that the result will be 30? You can raise your hand.
Does input return a string or an int?
Yes, so that's the point. So here, if I just run it, let's say 10, and you will see that it ended up in an error, because whatever you will input, it will be read as a string, not as an integer. So here is a type mismatch. You want to add an integer with a string, which cannot be done. So in order to do that, you have to change it to this int or something like this. So it is the user's responsibility to change the string. Sorry, it should be in var1 like this. And now if you just run it, you will see that you will get the proper output. So basically it is being read as a string. So take another one moment to think about how you can check the type of the variable. So print, so let's say instead of just typing this, let's call it type and then var1. So what should it print instead of just the number is, or let's call it the type of number is. If I run it, it's a 10. So what is something is yeah, so it should be when you want to add a string, you have to use a comma, otherwise you can use a plus symbol. So that was a syntax error in Python. So as you can see, it have been detected as a string. So that's why you have to change it to an integer explicitly. That's the developer's responsibility. Any question? Did you all understand it? All right, so if it is clear, now let's take a 1 minute break, and then let's say 3 minutes break, or let's come back around like 11:20 when I will start about branching and looping, which are a little bit more involved programming. And so
I have a question in the chat.
oh, okay, sorry. Sure. Can I use the output of a variable in one code block in the next code block? Yes, you can. I believe you can. So I think this is your question. So let's see. Let me get you two code blocks. Let's say, what is name? IK variable. So let's call it variable underscore height, and let's do like 10. All right. And now let's do like print variable like here. So is that your question, Heike? Whether I can use this variable over here? So if your question is that, so here 10 is stored in var Heike, and then if I just run it here, you will see that 10 is printed. So yes, you can use it everywhere.
Seems like once I set a variable, it just stays set.
Yes.
Seems kind of weird.
Because the major motivation for this Jupyter style notebook is like you will download the entire code and it will give you an entire bulk code which you can run in bulk mode instead of just this interactive. You can run in a batch mode actually. So yes. So these things, whatever, I can understand the intuition behind the question because I am using this var1, var2 many different times in many different blocks, but these are just for the sake of easy demo so that you can get everything self-sufficient code in each block. But yes, they retain the states. All right, let's start after 2 minutes, but feel free to ask me any type of question if you have. I am here.
Time to be around.
Yes,
Might be a
sure.
good break at some point.
Right. Yeah, what? All right, I think we should start and we can go around the room, Dr. Lawler. It's 11:20.
Yeah. I mean, please feel free.
Yeah, let's stop the sharing for here. So, all right. So since we learned a lot of, wrote a lot of code, so now we think it's a very good time to learn about your background. We skipped that part because we started a little late. So let's go over the room once again. So maybe Dr. Lawler. So let's start from Hazel, right, Dr. Lawler? The first person. All right, so please feel free to unmute yourself and let us know a little bit of your background and like so. Why are you here for? What is the major motivation, or what type of topics you want to see in our future workshop, something like that. So let's start from the first person, Hazel. Maybe we can move to Megan McPhee.
Hi, yeah, I'm faculty in the fisheries department and I use R a lot, but I don't really write my own functions, but I would like to learn Python because I have some DNA sequencing data that I would like to be able to play with more.
Great.
Thanks for offering this.
Perfect. Next is Daisy Huang.
Hi, I'm Daisy Huang. I am in CEM in mechanical engineering. I do research with the Alaska Center for Energy and Power, and a lot of our work is modeling power behavior when you integrate different amounts of renewables. So I just wanted to learn about this. And thank you so much. It's super useful.
Thank you. Randy Fulweber.
Hi, good morning. I'm Randy Fulweber. I'm the GIS and remote sensing manager for Tulit Field Station, and our spatial GIS program uses a lot of Python. So I'm interested in learning more, especially NumPy and Pandas. Thanks.
Ty Golden.
Yes, hello. My name is Ty Golden. I'm a part-time MS student for petroleum engineering. And I'm interested in the intersection of petroleum engineering and data analytics and machine learning. And that's something I think I want to work towards using for my thesis. Thank you.
Cool. And Emily Steedham.
Yeah, I'm Emily Stem. I'm a master's student in the oceanography department, and I'm looking to use Python for more customization for my graphics.
Great. Walter. All right. 14. Learning. Okay, perfect. Cool. Welcome, Walter, for the coding. Dane Harmon.
Hey, I'm actually a CS graduate, but I saw a thing about learning about data science, which is something I didn't really touch when I was studying EUAF, and I figured, why not? And I'm also interested because I work with a couple of non-primary coders on how to teach coding. So this is also interesting to me for that as well.
I think Hazel is on here. Hi, Hazel.
Looks like fall.
You have to unmute yourself. So
yeah, sorry. Hey, yeah, no, I'm using another computer. Hey, my name is Falk Whitman. Yeah, we've done many coding things. I like to learn more about the editors you're using there. It's an interesting one. I hadn't seen that before, but yeah, I do a lot of statistical work and GIS as well. Thanks so much for the class. Thank you. Hi, everybody.
Thanks. Next is Ibrahim Gorbani. All right, let's move to Jax Philip.
Hi, I'm a faculty at the Center for Alaska Native Health Research, and I do some statistical work there. I've had some experience with Python for web programming, but I want to learn more about using it for data science and machine learning.
Great. Dana Brown.
Hi, I'm an ecologist of research faculty at IARC, and I do applied remote sensing. And I'm currently learning how to work with Google Earth Engine, mainly programming in JavaScript, and I'd like to learn Python as well.
Perfect, cool. Heike Markel.
Yeah, hi, I'm with the Alaska Center for Energy and Power, and we are using Python notebooks to process images, also in Google Cloud, Google Earth Engine, and I'm part of the team, so I'm trying to figure out how this works.
Great. Thales Levinsky Pereira.
Hi everyone. I'm a postdoc position here in the museum, and I also work with DNA barcode to study fly biodiversity. So I was interested in learn a little bit to work with these sequences to make my life a little bit easier. Thank you for the course.
Great, great, great. Cody Hound.
Hi, I'm Cody. I'm a first year PhD student. I'm working on microbial interactions, so a lot of R work. And I'm, for the most part, just been expanding kind of my programming knowledge. So that's why I'm here.
Sure, thank you. And Hongli Chang. Okay, let's move to Eric K. All right, so and here in person, we got only one in-person student. Thanks for showing up here.
Thanks for having me. I'm Luke. I'm an MBA student, and I wanted to learn more about what all these coding people do.
Okay, cool. So did I miss anyone in the room? All right, so well, we got persons from MBA, we got persons from museum, we got persons from biology, IRC, remote sensing, so really multidisciplinary. So thanks for showing up first of all. And one more thing, I mean, if you have any type of question in data science, and if you need any type of computer or programming help for your research purpose or for your project purpose, please feel free to send us an email and we will be happy to help in your project. So, and well, this workshop will be there, and we'll be happy to help in here also. So yeah, and Dr. Lawler, do you want to say something? No? Perfect. Okay, so now let's move again to coding. Okay, so can you all see my screen once again? All right. So now what we will do, we will learn a more involved coding now, and let me switch back to my PowerPoint, and all these things I have already covered with hands-on. And now we will learn about this control structure, which basically determines how the program will flow. Okay, so now in any type of programming language, not only Python, there are three different types of control structure. The first one is sequential control structure, branching control structure, and loop control structure. So sequential control structure is just the way what you have seen so far, one line at a time, and the code is executing lines after lines, instructions after instructions. First storing a variable, then printing the variable, perform some arithmetic operation, then printing the variable, like that. And now it's the time to learn more about branching. Sorry for a little bit mess up in this slide anyway. So here, so branching, the best way to think about branching is just thinking about the real world situation when you are driving and you are in front of a fork. And you saw a board that, well, if you want to go to the forest, take the right road. And if you want to go to the city, then you take the left highway. All right. And now it's up to you, like what type of decision you want to take. If you decide to go to forest, you have to take one path, the right path. If you want to go to city, you have to take the left path. So it's basically up to your decision. So based on some sort of condition or based on some sort of decision in your head, you are basically taking one way that you want to travel. The same thing happens in programming also. And in order to do that, we have to make use of a keyword which are called if and else in here. So here this simple thing like, well, the program instructions will, instruction will flow in a sequential fashion over here. After that, there will be some kind of decision making box, if condition or something. And if the condition is true, it will execute some instruction, just like taking the right road or left road. And if it is false, then you have to go through the other way, just like this left, the other way. So, and here this Python code is basically the exact representation of the situation that I have just described, like driving the car and deciding whether to go to forest or city. Here, let's say instead of where, let me give a nice name called decision. So if you decide to go to, so let's say you want to decide to go to city. Now you are saying the program like, well, if my, let's give a small name, let's say instead of decision, let's do it DC. So instead of if my decision is city, then go left, otherwise go right, something like this. All right. So let's take an example. Let's go to our Google Colab in order to get some hands-on example. So here is branching. Now branching syntax is like, the branching syntax is always like this. It should make use of if and else. So if, then followed by inside a parenthesis, you have to write down the condition based on which you want to branch. So if it is true, then execute, if this execute some part of code, else execute this part of code, something like this. So here is the example. So just like that, let me change the variable name to, let's call it decision, and that will give you some intuition behind it. And so I just changed the variable name. So let's say you decided to go to the forest. So you store your decision variable is taking the value forest. And now here it is the if condition, then inside this opening and closing parenthesis, you are checking or you are comparing the values, like whether my decision, what is my decision? So if my decision is equal to the value city, then print go left, and otherwise print go right. Now, the part of statement, coding statement that you want to execute, that should be written after this colon symbol and then tab or some space over here. All right. Now, let me show you something. So here, let me first run this program. And as you can imagine, so decision is forest. Now here it is checking whether the decision is equal to city or not. Of course, the decision will be false over here because city is not equal to forest. So if I just run it, it will directly, okay, so it will directly go to the else part, because this decision is false, means it will go directly to the otherwise part and printing go right. And if you just make it like this city, and you will of course get this go left. So if the value of decision is equal to city, which is true now, that's why it is executing the part after if, inside if, or otherwise if the variable is not city, it will go directly into the else part. All right. So now any question? Did you understand? I got a question, I think. Oh, I'm sorry. One second. All right, thank you, Cody. So here it is. So if so like that way, you can take the decision in your program based on the value of the decision. The code will execute. A selected sequence of code will be executing. Now in Python, there is a syntax related tricks that you should always remember when you are going for this branching or looping and like that. You have to put proper tabs in here. Okay, so especially if you are coming from a background like C++ or Java, something like that, they really do not care about these spaces before this line. But in Python, once you will give some kind of colon symbol or this if symbol or something, you have to give a tab like this. Otherwise, what will happen? Let me do this. And as you can see, the program is throwing an error. All right, so if I just do it, you will get an error. So if you make the compiler, want to make the compiler understand that, well, these are the code sequence that will be executing upon successful testing of this decision or this condition, you have to put a tab and else also here. So that's a tricky thing in Python, and I'm not really sure why the Python developers kept it in this way, but it is what it is. All right, the parentheses after if are not required, unlike in R. So let's do that in here, and let's do like this. And as you can see, it is also working. But well, normally as a programming, as a computer experts, we always recommend that you should put everything inside parentheses. That's a good programming practice that increase the readability of your code. That's why. But you can ignore these parentheses, of course, as I have shown. So all right, so now that is if and else. Now all the time in our real life, it is not possible to do a two-way decision. Two-way branching is not always solve the situation. There can be multiple different things. For example, let's say instead of let me go to my PowerPoint, and so let's say instead of going to this forest or city, now if you want to go to this, let's say village, or let's say if you want to go home, then what will you do? So that's kind of a multi-way branching. There are lots of different options. Only two-way branching, if and else, cannot solve it. In order to do that, Python has a keyword called elif. Now you can add as many elif as you want in between if and else condition. So if will start some kind of condition, then a lots of different condition, and else will end everything. So like that way, you can add multiple different branch. So for example, let's go to this coding window again, and let me just copy paste this code over here. Just to give you the idea like how it works. So it is if and else. Now let's say inside this, in between this if and else, I am writing like elif this decision, let's say instead of city or forest or something like that, let's say if you want to go to some village, village, and so here just print go straight. All right, and now if you just run it, everything is okay. Now let's say if you have another option, you added another option, if you decided to go to village, the program will guide you where to go. So it is directly come to this this code block where this is true, and it is printing this go straight. So as you can see, and now this is not the only you are allowed to I mean, you can add any number of elif statement as you want. So let's say this is like this, and let's say if I want to decision, I want to go to moon. All right, so like that way, and let's say you can do like, all right, go up. So something like this. And if I just decide to go to moon, and if I just write it down, it will print go up. So basically they are checking all these different conditions, and whichever is true, that corresponding print statement is executing. Now, it's not about just writing one print statement over here. You can do any line, any number of code. You can add any number of code. You can perform any type of operation upon successful comparison or something like that. So for example, let's say it is print go left. Let's say print it is vibrant. All right. And next, let's say if I go to village. So just to go give you the idea, like you can add as many number of lines of codes in each of these things. You can do like that. It is quiet. So if you go to village, it is quiet. And if you go to moon, let's call it print. Oh, sure. All right. So like this, and otherwise go right, print default. All right, so here it is. And so as you can see, I am now executing two different print statements. So let's see what happens if the decision is moon. And if I just print it, as you can see, this piece of code block is executing and it is saying that go up as well as it is printing. Are you sure? All right. So that's how you can add multi-way branching in your program. All right. So this is one way of doing this multi-way branching. Now, if we get some time in the next lecture, I will talk more about this if else. There are several other things like nested if else inside an if else, if and else block, something like that. But we will keep it for the next lecture if required. But this is the basic branching, multi-way branching or two-way branching in Python. So any question? Did you all understand this branching? This is a very important thing in coding. Many times you may have to just check two different values, whether they are coming all right, or I mean, whether they are comparing equal or less than or greater than, any type of comparison. And based on the comparison, you have to decide which piece of code you want to execute. So if else is your decision blocks. Any question? So if you want, take, let's say, 2 minutes to write down this code and get yourself familiarized with this Python if, elif, and else. So, and one more thing, just to guide you to for your easy learning, this L is basically stands for an else. Okay, so what it is basically doing, this L means otherwise. L stands for else, so it means otherwise, which basically means that if this condition is not true, means else, and then again adding an extra condition over here. All right, so like that way it works basically. All right, any question regarding if, elif, and else? So mostly many of the data science problems needs this type of decision making, which is an important part of data science, the decision making. So here, there you will get a lot of different situations where you have to use this branching. So, all right, if you do not have any question, then let us move towards looping. Looping is the other type of control structure, which basically means repetitively execute some lines of code. So let me switch back to my PowerPoint once again, and let me show you about the loop. So loop is basically, so let's say the easiest way to visualize a loop is basically thinking about a sprint or a racing track. It can be a car racing, it can be a motocross or whatever. All right, so here basically just think about the fictitious race or sprint where the race will finish after the lap 4. So means every competitor needs to run for 4 different laps. So what each competitor does, each of the competitor first starts from lap 0, and then the competitor starts running. All right, and then what the competitor does is, in the end of every lap, the competitor increment the lap count. All right. So, and that's how it just keep track of how many lap have been completed. And then until the competitor basically runs until the lap count is 4. And once the lap count is 4, it just break the loop or get out of the sprint and the race is finished. So that's what is happening. And the exact the coding representation can be shown using this left-hand side diagram, where it will just, if there is a condition, if it is true, then the some set of instruction over here will repetitively execute and execute and execute. And once it is false, it will just come out of that iteration or loop. Now, and this part is basically the exact representation of the code that situation that I have just explained. So here, basically, in order to write a Python code with a loop, you have to use a keyword called while. So whenever you will use the keyword while, it will tell the Python interpreter that, well, I want to go inside a loop, just like our I want to go inside our racing track. It's just like firing the gunshot before you start the sprint. Once you will write while, the gunshot is fired in the programming context. All right. So what I am doing here, just see this sequence and just try to match it. So here lap equals 0. And what I am doing here is, after while, I am just checking how long the race is inside parentheses. So here I am saying that, well, run until the lap is less than or equals 4. Do not stop. All right. And then just in this line, I just wrote it for my purpose, but here it is the exact situation. So if in the end, so once the lap is not equals 4, when the lap is less than or equals 4, then the competitor is basically running, which I have represented by printing run statement. And then the lap count is basically incrementing by the end of this loop, like this. All right. And finally, once everything is done, you're printing out of the loop. Okay, so this is the exact representation of this situation. So let's take the loop, take a look at the Jupyter notebook, what is happening over here. So basically just here, what I am doing, first I am starting with lap equals 0. And here I am saying, like, while the lap is less than 5. Now, this is same as writing less than or equals 4 means less than 5. So basically both are same. So here I am writing this lap is less than 4. Then I'm typing this like print run. So the competitor will keep on running. And by the end of this loop, I'm just incrementing the lap count. Okay, so here basically the gunshot is fired, the competitor started running, and after end of each lap it is incrementing the count, and then it will just run over and over the same track again and again, and once it is done it will come out of the loop like this. So let us run this program first, and then I will explain this. So if I run this program, you will see that this run means for every lap, 1, 2, 3, 4, 5 times run have been printed, and then it is yes, the lap plus equals 1 will also work. So that's a great question. So it is lap plus equals 1. Heike asked that whether it will work or not. Yes, it will work. So no problem in that. So I just wanted to be explicit. That's why I use that. So anyway, so here it is. So now, as you can see, run is printed 5 times, and then it is printing out of the loop, means the loop is broken. So what is happening now? Let's try to understand. So loop is basically controlled by a variable called loop control variable, which is lap in our case. In a sprint, lap is all about everything, right? It controls the entire race. So here it is lap. Then inside while, then inside a parenthesis, we just give the condition until when the race or the loop will continue. Here it is lap is less than or equals 4. And then the lap control, then the body of this loop like this in here, and finally the incrementation. Now what is happening here? Lap is initializing to 0 first. Now it is checking the condition whether 0 is less than or equals 4 or not. And well, of course, 0 is less than or equals 4. So it went inside the loop and printed run over here. All right. And then it is basically, so it printed run for the first time over here and then went to the end of the loop line, and it is incrementing the lap count by 1. So at this point of time, the value of lap is 1 because it incremented from 0 to 1. So now from here, it will again go to the first line of this loop. Now it will check while 1 is less than equals 4 or not, because lap variable count is changed. And so yes, once again, 1 is less than equals 4. So it will go inside the loop, print run for the second time, and it will increment the lap variable once again. That will be 2, and like so. So in this way, what it will do, it will go to 2, again 2 less than equals 4, which is true. So print run for third time and increment it to 3. So again, 3 is less than 4, print run for the fourth time. And of course it is okay. So it will print, increment it to 4. And so, sorry, it is 3 and like that. So after 3, it will just come here and increment it to 4. And for the last time, so it is 4 less than equals 4, it will check. And since it is 4 less than 4 less than equals 4, it is true because of this equals symbol. It will go inside the loop again, and it will print this run for the last time. That's it. And then what it will do is it will increment the lap from 4 to 5 over here. Now it will go again to the first line. It will check whether 5 is less than equals 4 or not. Now this time it is false, and that's why it will not go again inside the loop, but directly break the loop, come out of the loop, and print this out of loop. So every time, always you should remember that lap variable is incrementing and the loop is broken in the condition checking line. It is not breaking in the last line of the code. Once the condition is false, then it will break the loop instead of going inside it. That's how the thought process of a program will be, not like just in the last line the code is breaking or something like that. Loop is broken. And so always whenever you will explain the condition, always explain like loop until this condition is true, or let's say iterate whenever this condition is true, something like that. So that will give you the clear conscience of a loop variable. I mean, how the loop works actually.
Sorry, loop while this condition is true, right?
Sorry, loop while this condition is true. Yeah. So like this way, you should think about it, not on the basis of the false thing. I mean, when the condition is false, but always start thinking like this, and that way your idea will be clear. So here,
suggestions in the chat.
Yeah, here actually I got a question. I didn't have the tab in front of the lap +1, so got stuck in the, yes, exactly. So as I told, whenever you are writing the code upon successful condition in Python, you have to have a tab, because that's the only way to tell the Python interpreter that this will only execute in when the condition is holding true. So if you just do something like this, well, if I just run it, I may need to refresh the code once again, and it is just an infinite loop, because right now this while loop, the code line is just stuck in this print statement. I'm not sure whether it will stop for me or not. Well, okay, it did. That's good. So here, basically, always remember these increment line, it must be inside this loop basically. So just run this code. Yeah. So now it is working properly. So now here one thing another question, Dana told that I added print lap within the while check the lap increment. Perfect. Yes, exactly. Thank you. So yes, any one of you, if you want to check how the value of the lap is incrementing, that's possible. That's the next thing that I was going to describe. So here you can type the variable name over here. All right. And if you just run it, you'll see that the lap is starting from 0. It is going to 1, then 2, then 3, then 4, and every time it is incrementing. Thank you. So this way. And now the other thing that I would like to say that, all right, I have started from 0, but it does not need to start from 0 actually. The initialization can be anything. For example, let's say if you want to start from 10 or something like that, that can also be an initialization. So just take a few moments, like if you start from 10, whether the loop will execute at all or not really. So what will happen here? So just take like 10 seconds just to think about it, what is happening. So what is happening here? The first time, what will happen? It will start checking whether 10 is less than 4 or not. And since 10 is not less than 4, it is false. It will directly come out of the loop and everything is done. Okay, and there is nothing like that. So now if you do like 10 is less than 14, it will go like 10, 11, 12, 13, 14, something like this. Okay, and now once again, it can take any initialization form. It can take any type of conditions. It does not need to be just less than equals or something like that. You can do like greater than equals, let's say 10 greater than equals 14 until 4. Until that point of time, it will execute. And at that time, if I just execute it, can you tell me what should be the output over here? Should it be an infinite loop, or should it be, will the loop execute at all, or what will happen? The initial condition is 10, initialization is 10, and here I am checking 10 is greater than equals 4, and then print lap, and here lap is actually incrementing. So what will happen? Is it an infinite loop? Yes, exactly. So Cody told that it will be an infinite loop. So if I just do it, you will see that, well, it is incrementing and it is going on and on, because whatever it is, lap is 10, 10 greater than 4, it is good, it is true. So it will come inside the loop. Then it is 10 plus 1, 11. 11 is again greater than 4. Then 12 greater than 4, 13 greater than 4. And not only that, here, as you can see, 333K, 1 million every time it will work. So if you want to make it proper, you have to do like lap minus equals 1, which will decrement the lap from 10 to 4. So like this. So it's like that, 10, 9, 8, 7, 6, 5, 4. And not only that, you can use any type of arithmetic operation, or many other different types of operations are also possible to modify this loop control variable or this lap count to construct a proper loop. So that is the thing about looping. So, and so that's it. And in the last 1 minute, I just want to tell that, well, we have learned about while loop, but there is another keyword called for loop, which is basically the same. I mean, a twin of while loop, but the syntax is a little different. The underlying philosophy is all same. And so let's move to the first piece of code that I have written. Lap will start from 0 and lap will be less than equals 4, or we can just write down like lap is less than 5, both are same. And here again, I wrote like 10 plus equals 1, right? So like this, and we just type like print run over here, right? So in this way, sorry. So that was our initial version of code. And as you can see, like lab started from 0 and every time it is printing just a run and finally out of the loop after 5 times printing run. And now there is another thing called for loop, which is basically the same thing as while, but offers a more compact syntax. In while loop, for the initializing of this loop variable and then checking the condition and then modification of this loop variable, you spent like 3 different lines. But in for loop, you can do this entire thing in 1 line of code. So the first initialization is appearing as a parameter to a function called range, which is 0. Then lap less than 5, it is coming as the second parameter of range. And then lap plus equals then 1, it is coming like this 1 over here. And then you are printing run and out of loop. And as you can expect, the output will be exactly same as that we have done before. Okay, so that's about for loop. It's exactly similar, and possibly after a few days of programming, you will find this for loop is more comfortable than writing a while loop. Most of the time it happens because it is compact syntax. So we are stopping here and we will start from learning function and array and some things about NumPy and pandas in the next lecture. So if you need to have any question, please ask me now. So, okay, so if you do not have any question, maybe Dr. Lawler, you can conclude the session.
All right, so that's a huge amount of stuff to learn.
Oh, hi, there is one question.
Right.
Sorry for losing my introduction. Okay, Ibrahim told that he's an MSc in mining engineering, rock mechanics, and thanks, Ibrahim, for the introduction.
So our plan is to have one of these basically every week until we run out of semester or motivation. There's definitely going to be plenty of topics to cover. We're actually, there's been several requests for some artificial intelligence stuff, which honestly, the same set of tools should be useful for all of those things. So yeah, feel free to email Dr. Doss or me, Dr. Waller. And yeah, this was good. I actually learned more Python than I knew, so that's good. All right.
Someone asked, like Dana asked, like, will the recording be available? So yes, we will share the recording. We already recorded. Maybe the first 2 or 3 minutes were missing, yeah. But after that
we should see if we can get people a copy of your notebook and maybe your slides.
Yes, that's what I'm going to do. What is the best way? So if you did not register in the Google form, please do so. And I will get all the email ID from there, and I will send the copy of this notebook to all of you.
Awesome. Thanks for
thank you.
Calling us.
Thank you. Thanks for showing up. Thanks for attending.
Yes, thanks.
Thank you. Right, I think we can stop.
Thanks, that was super insightful. Yeah, thanks for having me.